architecture of Docker so you understand how it works. Then we're going to install Docker and get our hands dirty. I'm going to give you an overview of your development workflow with Docker, and then we're going to see that in action using a really simple example. So by the end of this section, you will have an idea of what Docker is all about. I'm so excited about this section. I hope you are too. So let's jump in and get started. So what is Docker and why is everyone using it these days? Well, Docker is a platform for building, running, and shipping applications in a consistent manner. So if your application works on your development machine, it can run and function the same way on other machines. If you have been developing software for a while, you've probably come across this situation where your application works on your development machine, but doesn't somewhere else. Can you think of 3 reasons why this happens? Well, this can happen if one or more files are not included as part of your deployment. So your application is not completely deployed. It's missing something. This can also happen if the target machine is running a different version of some software that your application needs. Let's say your application needs Node version 14, but the target machine is running Node version 9. This can also happen if the configuration settings, like environment variables, are different across these machines. And this is where Docker comes to the rescue. With Docker, we can easily package up our application with everything it needs and run it anywhere on any machine with Docker. So if your application needs a given version of Node and MongoDB, all of these will be included in your application's package. Now you can take this package and run it on any machine that runs Docker. So if it works on your development machine, it's definitely going to work on your test and production machines. Now there's more. If someone joins your team, they don't have to spend half a day or so setting up a new machine to run your application. They don't have to install and configure all these dependencies. They simply tell Docker to bring up your application, and Docker itself will automatically download and run these dependencies inside an isolated environment called a container. And this is the beauty of Docker. This isolated environment allows multiple applications use different versions of some software side by side. So one application may use Node version 14, another application may use Node version 9. Both these applications can run side by side on the same machine without messing with each other. So this is how Docker allows us to consistently run an application on different machines. Now there's one more benefit here. When we're done with this application and don't want to work on it anymore, we can remove the application and all its dependencies in one go. Without Docker, as we work on different projects, our development machine gets cluttered with so many libraries and tools that are used by different applications. And then after a while, we don't know if we can remove one or more of these tools because we're always afraid that we would mess up with some application. With Docker, we don't have to worry about this. Because each application runs with its dependencies inside an isolated environment, we can safely remove an application with all its dependencies to clean up our machine. Isn't that great? So, in a nutshell, Docker helps us consistently build, run, and ship our applications. And that's why a lot of employers are looking for people with Docker skills these days. So if you're pursuing a job as a software or DevOps engineer, I highly encourage you to learn Docker and learn it well. And that's exactly what this course is all about. I'm going to take you on a journey and teach you everything you need to know about Docker so you can use it like a pro. No copy-pasting commands here. So in the last lesson, I briefly talked about containers. A container is an isolated environment for running an application. Now, one of the questions that often comes up is, how are containers different from virtual machines or VMs? Do you know the differences? Well, a virtual machine, as the name implies, is an abstraction of a machine or physical hardware. So we can run several virtual machines on a real physical machine. For example, we can have a Mac, and on this Mac, we can run 2 virtual machines, one running Windows, the other running Linux. How do we do that? Using a tool called hypervisor. I know, it's one of those computer science names. In simple terms, a hypervisor is software we use to create and manage virtual machines. There are many hypervisors available out there like VirtualBox and VMware, which are cross-platform, so they can run on Windows, macOS, and Linux, and Hyper-V, which is only for Windows. So with a hypervisor, we can manage virtual machines. Now, what is the benefit of building virtual machines? Well, for us software developers, we can run an application in isolation inside a virtual machine. So on the same physical machine, we can have 2 different virtual machines, each running a completely different application dependencies it needs. So application 1 may use Node version 14 and MongoDB version 4, while application 2 may use Node version 9 and MongoDB version 3. All these are running on the same machine, but in different isolated environments. That's one of the benefits of virtual machines. But there are a number of problems with this model. Each virtual machine needs a full copy of an operating system that needs to be licensed, patched, and monitored. And that's why these virtual machines are slow to start because the entire operating system has to be loaded, just like starting your computer. Another problem is that these virtual machines are resource intensive because each virtual machine takes a slice of the actual physical hardware resources like CPU, memory, and disk space. So if you have 8 gigabytes of memory, that memory has to be divided between different virtual machines. Of course, we can decide how much memory to allocate to each virtual machine, but at the end of the day, we have a limit in terms of the number of VMs we can run on a machine. Usually a handful, otherwise we're going to run out of hardware resources. Now let's talk about containers. Containers give us the same kind of isolation, so we can run multiple applications in isolation, but they're more lightweight. They don't need a full operating system. In fact, all containers on a single machine share the operating system of the host. So that means we need to license, patch, and monitor a single operating system. Also, because the operating system has already started on the host, a container can start up pretty quickly, usually in a second, sometimes less. And also, these containers don't need a slice of the hardware resources on the host. So we don't need to give them a specific number of CPU cores or a slice of memory or disk space. So on a single host, we can run tens or even hundreds of containers side by side. So these are the differences between containers and virtual machines. Let's talk about the architecture of Docker so you understand how it works. Docker uses a client-server architecture, so it has a client component that talks to a server component using a RESTful API. The server, also called the Docker engine, sits in the background and takes care of building and running Docker containers. Now, technically, a container is just a process, like other processes running on your computer, but it's a special kind of process process, like other processes running on your computer. Number of CPU cores or a slice of memory or disk space. So on a single host, we can run tens or even hundreds of containers side by side. So these are the differences between containers and virtual machines. Let's talk about the architecture of Docker so you understand how it works. Docker uses a client-server architecture, so it has a client component that talks to a server component using a RESTful API. The server, also called the Docker engine, sits in the background and takes care of building and running Docker containers. Technically, a container is just a process, like other processes running on your computer. But it's a special kind of process which we're going to talk about soon. Now, as I told you, unlike virtual machines, containers don't contain a full-blown operating system. Instead, all containers on a host share the operating system of the host. Now, more accurately, all these containers share the kernel of the host. What's a kernel? A kernel is the core of an operating system. It's like the engine of a car. It's the part that manages all applications as well as hardware resources like memory and CPU. Every operating system has its own kernel or engine, and these kernels have different APIs. That's why we cannot run a Windows application on Linux, because under the hood, this application needs to talk to the kernel of the underlying operating system, okay? So that means on a Linux machine, we can only run Linux containers because these containers need Linux. On a Windows machine, however, we can run both Windows and Linux containers because Windows 10 is now shipped with a custom-built Linux kernel. This is in addition to the Windows kernel that's always been in Windows. It's not a replacement. So with this Linux kernel, now we can run Linux applications natively on Windows. So on Windows, we can run both Linux and Windows containers. Our Windows containers share the Windows kernel, and our Linux containers share the Linux kernel, okay? Now, what about Mac OS? Well, Mac OS has its own kernel, which is different from Linux and Windows kernels, and this kernel does not have native support for containerized applications. So Docker on Mac uses a lightweight Linux virtual machine to run Linux containers. All right, enough about architecture. Next, we're going to install Docker, and that's where the fun begins. All right, now let's install the latest version of Docker. If you have an existing version of Docker on your machine, I highly encourage you to upgrade to the latest version because your version might be old and not compatible with the version I'm using in this course. So here I'm using Docker version 20.10.5, okay? So to get Docker, go to this page, docs.docker.com/getDocker, or you can just Google get Docker or install Docker. Now on this page, you can see instructions for downloading and installing Docker Desktop for Mac and Windows, as well as Docker Engine for Linux. So on Mac and Windows, we have Docker Desktop, which is the combination of Docker Engine plus a bunch of other tools. At the time of recording this, we don't have Docker Desktop for Linux. We only have the Docker Engine. But of course, that might change in the future. So a couple of notes for my Mac and Windows users. Let's go to this page. So over here, you can download the latest version from Docker Hub. But before doing this, I highly encourage you to go through system requirements and make sure your computer satisfies these requirements. Otherwise, you might encounter weird issues. So the installation is pretty straightforward. When you go to this page, you're going to download a DMG file. Just drag and drop this onto the applications folder and then start it. This is very important. A lot of people miss that step. So when you start Docker Engine, by double-clicking on this application, you're going to see the Docker icon on the top status bar. If you don't see this, Docker Engine is not running and there's nothing you can do. So you have to wait for this to start. The same applies to my Windows users. So back to this page. Let's look at the instructions for Windows. So once again, you can download the latest version of containers. Its WS2 installation is your computer. Now, of the client and the server. So wait a little while, then open up a terminal window and run docker version. So over here, you can see the version of the client and the server. If the server, which is Docker Engine, is not running, you're not going to see this information. And this applies to all operating systems, Windows, macOS, and Linux. So make sure Docker Engine is running before going forward. If you encounter any errors, you can post your question on our forum at forum.codewithmosh.com. Or if you want a faster response, just Google the error message. I'm pretty sure hundreds of people have encountered the same problem as you. Now let's talk about your development workflow when using Docker. So to start off, we take an application. It doesn't matter what kind of application it is or how it's built. We take that application and Dockerize it, which means we make a small change so that it can be run by Docker. How? We just add a Dockerfile to it. A Dockerfile is a plain text file that includes instructions that Docker uses to package up this application into an image. This image contains everything our application needs to run. Everything. Typically, a cut-down operating system, a runtime environment like Node or Python. It also contains application files, third-party libraries, environment variables, and so on. So we create a Docker file and give it to Docker for packaging our application into an image. Once we have an image, we tell Docker to start a container using that image. So a container, as I told you, is just instructions that Docker uses to Dockerize it, which means we make a small change so that it can be run by Docker. How? We just add a Dockerfile to it. A Dockerfile is a plain text file that includes instructions that Docker uses to package up this application into an image. This image contains everything our application needs to run. Everything. Typically, a cut-down operating system, a runtime environment like Node or Python. It also contains application files, third-party libraries, environment variables, and so on. So we create a Docker file and give it to Docker for packaging our application into an image. Once we have an image, we tell Docker to start a container using that image. So a container, as I told you, is just a process. But it's a special kind of process because it has its own file system, which is provided by the image. So our application gets loaded inside a container or a process. And this is how we run our application locally on our development machine. So instead of directly launching the application and running it inside a typical process, we tell Docker to run it inside a container, an isolated environment. Now, here's the beauty of Docker. Once we have this image, we can push it to a Docker registry like Docker Hub. Docker Hub to Docker is like GitHub to Git. It's a storage for Docker images that anyone can use. So once our application image is on Docker Hub, then we can put it on any machines running Docker. This machine has the same image we have on our development machine, which contains a specific version of our application with everything it needs. So we can start our application the same way we started it on our development machine. We just tell Docker to start a container using this image. So with Docker, we no longer need to maintain long, complex release documents that have to be precisely followed. All the instructions for building an image of an application are written in a Dockerfile. With that, we can package up our application into an image and run it virtually anywhere. This is the beauty of Docker. Next, we're going to see this workflow in action. In this lesson, I'm going to walk you through a typical development workflow. Now, don't try to memorize anything in this lesson because I just want you to see the big picture. So everything I show you in this lesson, we're going to cover in depth later in the course. So here in this terminal window, I'm currently on my desktop. I'm going to create a new directory called Hello Docker, then go inside this directory and open it in Visual Studio Code. So I'm going to use VS Code as my editor, but you can use any editor that you prefer, okay? Now, in this directory, I'm going to add a new file called app.js. We're going to write one line of JavaScript code. You don't have to be a JavaScript developer. You don't even need to learn JavaScript. So just follow along with me. So here we're going to write console in lowercase .log hello Docker. So with this, we're going to print a message on the terminal. Let's say this is an application and we want to Dockerize this application. So we want to build, run, and ship it using Docker. So typically without Docker, if you want to ship this application, or more accurately, this program to a different computer, on that computer, we need to install Node, and then we can go to the terminal and type node app.js. So we get the output. So here are the instructions for deploying this program. We need to start with an operating system. Then we need to install Node, which is an execution environment for JavaScript code. Next, we need to copy our application files. And finally, we need to run node app.js. So we have to follow 4 steps just for a simple program. What if we were working with a really complex application? We would end up with a complex release document that had to be precisely followed. Now, this is where Docker comes to the rescue. We can write these instructions inside a Dockerfile and let Docker package up our application. So back to VS Code, we're going to add another file to this project called Dockerfile. So capital D and all the other letters are lowercase, and this file doesn't have any extensions. Okay. Now, VS Code is asking if you want to install the recommended extensions for Docker. We can go ahead with that. Good. So back to this Docker file. Here we write instructions for packaging our application. So typically we start from a base image. This base image has a bunch of files. We're going to take those files and add additional files to it. This is kind of like inheritance in programming, okay? So what is the base image? Well, we can start from a Linux image and then install Node on top of it, or we can start from a Node image. This image is already built on top of Linux. Now, how do I know these names? Well, these images are officially published on Docker Hub. So if you go to hub.docker.com and search for Node, you can see the official Node image here. So Docker Hub is a registry for Docker images. Now back to our Docker file. So we start from a Node image. Now, if you look at Docker Hub, you will see that there are multiple Node images. These Node images are built on top of different distributions of Linux. So Linux has different distributions or different flavors used for different purposes. Now here we can specify a tag using a colon to specify which Linux distribution we want to use. For this demo, I'm going to use Alpine, which is a very small Linux distribution. So the size of the image that we're going to download and build on top of is going to be very small, okay? So we start from that image. Then we need to copy our application or program files. For that, we use the copy instruction or copy command. We're going to copy all the files in the current directory into the app directory into that image. So that image has a file system, and in that file system, we're going to create a directory called app, okay? Now, finally, we're going to use the command instruction to execute a command. What command should we execute here? Node app.js. But this file is inside the app directory, so we have to prefix it with the directory name. Alternatively, here we could set the current working directory, workdir, to /app, And then we don't need to prefix this with the directory name. So when we use this instruction, all the following instructions assume that we're currently inside the app directory, okay? So these instructions clearly document our deployment process. Now, we go to the terminal and tell Docker to package up our application. So we say Docker build. We need to give our image a tag to identify it. So -t. Here we specify a name like hello Docker. And then we need to specify where Docker can find a Dockerfile. So we're currently inside hello Docker directory, and our Dockerfile is right here. So we use a period to reference the current directory. Let's go with that. Now you might be expecting an image file inside the current directory, but back in VS Code, look, there is nothing here because the image is not stored here. And in fact, an image is not a single file. How Docker stores this image is very complex, and we don't have to worry about it. So back to the terminal. To see all the images on this computer, we type docker images or docker image ls, which is short for list. So take a look. On this machine, we have a repository called hello Docker. In this repository, we have an image with this tag, latest. So Docker added this by default. We'll talk about this later in the course, but basically we use this tag for versioning our images. So each image can contain a different version of our application, okay? Now, each image also has a unique identifier. Here we can see when the image was created and the size of this image. So because we used Node from Linux Alpine, we ended up with 112 megabytes of data in this image. So this image contains Alpine Linux, Node, and our application files. And the total size is 112 megabytes. Now, if we used a different Node image that was based on a different distribution of Linux, we would end up with a larger image. And then when deploying that image, we would have to transfer that image from one computer to another. So that's why we use Node Alpine, because this is a very small image, okay? So we have built this image. Now we can run this image on any computer running Docker. So on this machine, which is my development machine, I can say Docker run, and then type the image name, hello Docker. And it doesn't matter which directory I'm in, because this image contains all the files for running our application. Now, look, we see the message on the terminal. Now, I can go ahead and publish this image to Docker Hub, so anyone can use this image. Then I can go on another machine, like a test or a production machine, and pull and run this image. In fact, I've done this before recording this video. So back to Docker Hub, look, I have this repository, code with mosh/hello Docker. Now we can take this image and run it on any computers. Let me show you something really cool. So let's search for play with Docker. Let's go to this page and log in. Here we need to sign in with our Docker ID. Anyone can create this ID on docker.com. So let's go ahead and start a lab. Over here, we can start a new virtual machine. So let's add a new instance. Now, this virtual machine is a blank machine. It only has an operating system, which is Linux, and Docker. So in this terminal window, if we type node, look, node command not found. So node is not installed here. But because we have Docker, we can pull and run the image that I published on Docker Hub. So let me maximize this window by pressing Alt and Enter. First, let's run Docker version. So on this machine, we're running Docker version 20.10.0. So to pull and run my program, first we type docker pull code with mosh / hello-docker. All right, Docker downloaded this image. We can verify it by typing docker. What command should we run here? Docker images or image ls. So on this machine, we have this repository, code with mosh / hello-docker. And this repository contains a single image with this tag, latest. So now we can run this application exactly the same way we ran it on my development machine. So from any directory, we can type docker run code with mosh / hello-docker. And here's the message, beautiful. Of course, I had to cut this down in editing. It took a little while to start this application on this very slow virtual machine, but you got the point. So we can take any application and Dockerize it by adding a Dockerfile to it. This Dockerfile contains instructions for packaging an application into an image. Once we have an image, we can run it virtually anywhere, on any machine with Docker. Hey guys, Mosh here. If you're serious about learning Docker, I actually have a complete Docker course on my coding school, codewithmosh.com. This tutorial you've been watching is a cut-down version of the complete course. In the full course, you will learn how to run and deploy a full-stack application with a front-end, back-end, and a database. Our application also includes automated tests, so it's a great real-world scenario for learning Docker. Just like my other courses, you will also receive a 30-day money-back guarantee and a certificate of completion you can add to your resume. In case you're interested, you can find the link down below in the description box. All right, the next step in our journey is the Linux command line. But why Linux? What if you're a Windows user? Well, you still need to know a bit of Linux for a number of reasons. For starters, Docker has its foundations built on top of basic Linux concepts. So if you want to be productive and troubleshoot issues easily, you need to know some of the basic Linux commands. Also, most tutorials online are based on Linux commands, so if you don't understand these basic commands, you're not going to get far. In my opinion, learning Linux is like learning English. I think everybody should know some English these days. You don't need to speak it or write a book in it, but you need to understand it. So unless you're a power Linux user, do not skip this section. It's going to be super easy and extremely useful. So let's jump in and get started. Let's start off this section by talking about Linux distributions, also called Linux distros. So as you probably know, Linux is open source software. And for this reason, many individuals and communities have created their own version of Linux called Linux distributions. Each of these distributions is made to fit specialized needs like running servers, desktop computers, mobile phones, and so on. So we have Ubuntu, which is one of the most popular Linux distributions. We also have Debian, Alpine, which we briefly talked about. It's a very small Linux distribution. We also have Fedora, CentOS, and so on. Believe it or not, there are more than 1,000 Linux distributions out there. Now, most of these distributions support pretty much the same set of commands, but sometimes you might discover differences along the way, so be aware of that. In this section, we're going to use Ubuntu Linux because it's one of the most popular distributions. But if you have a preference for another distribution, that's totally fine. All right, let's see how we can run Ubuntu on this machine. From this lesson, I want you to start taking notes. So watch this video, take some notes, and then after the video, repeat the steps I have shown you, okay? So we go to hub.docker.com and search for Ubuntu. Over here, you can see the official Ubuntu image that's been downloaded more than 10 million times. Let's have a quick look here. So for each image, you can see the command to pull that image onto your machine. Now in this lesson, I'm not going to use the pull command. I'm going to show you a shortcut. So here in the terminal, instead of running docker pull Ubuntu, I'm going to run docker run Ubuntu. Now, if you have this image locally, Docker is going to start a container with this image. Otherwise, it's going to pull this image behind the scene and then start a container. So take a look. See, Docker is unable to find this image locally, and now it's pulling it from Docker Hub. Now, what happened? Well, Docker started a container, but because we didn't interact with this container, the container stopped. Let me prove this to you. So if you run docker ps, we can see the list of running processes or running containers. Look, we don't have any containers running here, but if you type docker ps-a for all, we can see the stopped containers as well. Let me increase the size of this window so we can see it clearly. Good. So we have two stopped containers. The first one is using the Ubuntu image. This is the one that we just started. And the second one is hello Docker, which we started earlier in the course. So to start a container and interact with it, we have to type docker run -it, that is short for interactive. We're going to start a container in the interactive mode. And in this container, we're going to load the Ubuntu image, which we have locally. Good. Now, what we have here is called the shell. A shell is a program that takes we have here is called the shell. A shell is a program that takes our commands and passes them to the operating system for execution. Okay. Now, what we have here is called the shell prompt. Let me break it down for you so it doesn't look mysterious. The first part, root, represents the currently logged in user. So by default, I'm logged in as the root user, which has the highest privileges. Then after the @ sign, we have the name of the machine. So this container has this ID, which is automatically generated by Docker. And in this case, it's like the name of a machine, okay? Then after the colon, you can see /. That represents where we are in the file system. A / represents the root directory. That is the highest directory in the file system. We'll talk about that soon. Then we have a pound. And this means I have the highest privileges because I've logged in as the root user. If I logged in as a normal user, instead of a pound, we would see a $, okay? So in this shell, we can execute a bunch of commands. For example, we can say echo, hello, and this prints hello on the terminal. We can also say, who am I? This shows the current user. So these commands that we're running here, this shell program that I told you about, takes these commands and passes them to the kernel for execution. Now, let me show you something really cool. If we type echo $0, we can see the location of this shell program. Take a look. So that is /bin/bash. So bin is a folder or a directory. And inside this directory, we have a program called bash, which is short for born again shell. So apparently, Steve Bourne is the first person who created a shell program. Bash or born again shell is a reference to Steve Bourne. So bash is an enhanced version of the original shell program, okay? Now, one thing you probably noticed is that in Linux, we use a / to separate files and directories. But in Windows, we use a \. So that's one of the first differences. The other difference is that Linux is a case-sensitive operating system. So if you type echo with a capital E, it's not going to work. Bash tells us echo command not found. So lowercase and uppercase letters are different. And this is not limited to commands. It's applicable everywhere. If you want to reference a file or a directory or a user, pretty much anything, we should always spell it properly with the right uppercase and lowercase letters. Now, one last thing for this lesson. Using the up and down arrows, we can go through the commands we have executed so far. So this is a pretty useful shortcut you need to know because you don't want to type these commands manually all the time, okay? Also, using the history command, we can see all the commands we have executed lately. So take a look. So earlier we used who am I, we also used echo and so on. Now we can replay any of these commands by typing an exclamation mark followed by the command number. So if I type 2, this is exactly like running who am I. Now it's your turn. I want you to pause the video, go through your notes, and execute the commands I have shown you in this video. These days, most operating systems and development platforms come with a package manager. You've probably worked with tools like npm, yarn, pip, and so on. Here in Ubuntu, we also have a package manager called apt, which is short for Advanced Package Tool. So let's execute this command. Look, this command has a bunch of subcommands. So using list, we can see the list of packages. We can also search for them. We can show details about the package. We can install, reinstall, and remove a package, and so on. Now, technically, apt is the newer package manager. We also have apt-get, which you see a lot in online tutorials. Going forward, we're going to use apt because it's easier to work with. So let's say we want to install a package called Nano. Nano is a basic text editor for Linux. Now, if you press enter here, we get an error because this image, this Ubuntu image we are running, does not have Nano. So this is where we use apt to install this package. So if we type apt install nano, we get an error saying unable to locate package nano. Why is this happening? Well, here in Linux, we have a package database, and this database might contain hundreds of packages, but not all these packages are installed. So if you want to see all the packages in this database, we type apt list. Look, these are all the packages. Now, in front of these packages, you can see some of them are installed, but not all packages in this database are installed. When we type apt install nano, this command looks at the package database, and in this database, it cannot find a package called nano. So this is where we use the update command to update the package database. Now, when we press enter, Linux is going to all these sources like security.ubuntu.com and all these other websites to download the list of packages. So now our package database is updated. So if we run apt list, we see far more packages. And as you can see, most of these packages are not installed because we don't have installed in front of them. So now we can run apt install nano, and nano is installed. So here's what you need to take away. Before installing a package, you should always run apt update to update your package database, and then you can install a package like nano. Now we'll talk about nano later in this section, but before going forward, let's make sure that this package is installed properly. So if you type nano, great. So here we have a text editor, we can type something. Let me resize the window. So down below, you can see the shortcuts. To exit, you have to press Control and X. Now it's asking if you want to save the changes. No, so we're going to press N. Good. We're back here. We can clear the terminal window by pressing Control and L, okay? So we have installed nano. Now let's say we want to remove it. So we type apt remove nano. It's asking for confirmation. Let's go ahead. Great. So nano is gone. If I type nano, we get this error saying no such file or directory. Now here's a little exercise for you. In this image, we don't have Python, so we get an error. So I want you to use apt to install Python in this image, make sure it works, and then remove it. So in Linux, just like Windows, our files and directories are organized in a tree, in a hierarchical structure. So in Windows, we have a structure like this, with C drive on top of the hierarchy. Then below that, we have directories like program files, Windows, and so on. In Linux, we have the root directory on top of the hierarchy. Below that, we have a bunch of standard directories. For example, we have bin, which includes binaries or programs. We have boot, which includes all the files related to booting. Then we have dev. The first time I saw this, I thought this is short for development. It's not. It's short for devices. So in Linux, everything is a file, including devices, directories, network sockets, pipes, and so on. So the files that are needed to access devices are stored in this directory. Then we have etc. There are different opinions. What is this short for? But one common opinion is this is short for editable text configuration. So this is where we have configuration files. We also have home. This is where home directories for users are stored. So on a machine with multiple users, each user is going to have a home directory here. We also have root, which is the home directory of the root user. Only the root user can access this directory. Then we have lib, which is used for keeping library files like software library dependencies. We have var, which is short for variable. And this is where we have files that are updated frequently, like log files, application data, and so on. And finally, we have proc, which includes files that represent running processes. So once again, in Linux, everything is a file. Processes, devices, even directories are files. Now, you don't need to memorize any of these directories. I just listed them here, so as we go through the course, these directories look familiar to you. That's all. Next, I'm going to show you how to navigate the file system, and there you will see these directories one more time. Let's see how we can navigate the Linux file system. So the first command we're going to talk about is pwd, which is short for print working directory. With this, we can see where we are in the file system. So a / represents the root directory. Now to see the files and directories here, we type ls, which is short for list. So we have bin, which we talked about earlier, that is short for binaries. This is where we have binary files and programs. We have dev, which includes files for devices. We have boot, which includes boot files, etc, which includes configuration files, and so on. Now, by default, ls lists these items on multiple lines. If you don't like this layout and want to show one item per line, you need to pass an option, that is -1. You might prefer this layout. We have another option, -l, for seeing a long listing. This listing includes more details. So in the first column, we have the permissions of this file or directory. The first time you see this, it might look really scary, but trust me, it's easier than you think. We'll talk about that later in this section. Over here, you can see the user that owns this file or directory. We can see the size, we can see the date, and so on. Now, to change the current directory, we use the cd command. We have the same command in Windows. Now here we can type a relative or an absolute path. A relative path is relative to where we are. So in this root directory, we have directories like bin, boot, and so on. So this is a relative path. Now, in contrast, an absolute path always starts from the root directory. So let's go to a directory starting with E. Now we can press tab to get auto completion. Beautiful. Now let's go to a directory starting with A. Now if you press tab, nothing happens because we have multiple directories starting with A. So we have to press tab one more time. Great. So we have 3 entries, 3 directories, add user.conf, alternatives, and apt. So let's type the second letter, P, and then press tab. Beautiful. Now let's see what we have in this directory. So these blue items are directories, and sources.list is a file. Now to get out of this directory, we can go one level up by typing 2 periods. Again, I'm pretty sure you're familiar with this, but I want to cover it to make this section comprehensive. So we can go one level up to get to the etc directory, or 2 levels up to get to the root directory. Look, we're currently in the root directory. Now, when using ls, we can optionally specify a path. Let's say I'm somewhere in the file system, but I want to look at the content of another directory. I don't want to navigate to that directory. So I'm currently in the root directory. I want to know what files and directories we have inside the bin directory. So once again, we can type a relative path or an absolute path starting from the root directory. So here are the binaries in this directory. Look at pwd. That's the command that we just executed. So pwd is a program in this directory. Here's another example. Look at echo. So most of the commands we have been exploring so far are programs or binaries in the bin directory. Okay. Now let me show you a shortcut. Earlier I told you that here we have this home directory where each user has a home directory, but the root user has a special home directory called root. Now to get here, there are 2 options. We can type an absolute or relative path and go to root, but there is a shortcut. So let me get out of this directory. So I'm currently in the root directory. To get to my home directory, I can type a tilde, and this applies to all users, not just the root user. Whenever we type cd tilde, we go to our home directory. Now, right now, there is nothing here, but in the next lesson, I'll show you how to create some files in this directory. So before moving on to the next lesson, I want you to spend a couple of minutes and play with the commands we explored in this lesson. Navigate the file system, get adventurous, see what you can discover. I'll see you in the next lesson. Let's see how we can manipulate files and directories. So I'm currently in the root directory, and I want to go to my home directory. How can I do that? Do you remember? We type cd tilde. Great. Now, in this directory, I want to create a directory called test. So we type mkdir test. Let's verify. It's right here. As I told you before, blue represents a directory. Now, let's say we want to rename this directory. How do we do that? We use the move command. With this, we can rename files and folders or move them somewhere else. So we can move or rename test to Docker. All right, beautiful. Now, let's go in this directory. Now, to create a new file, we use the touch command. So we can create hello.txt. Look, we have this new file here. This is a new empty file. In the next lesson, I will show you how to edit files. So for now, don't worry about it. Also, using the touch command, we can create multiple files in one go. So we can create file 1, file 2, and file 3. Now take a look. Beautiful. Now I've got a question for you. How do we list those files with a single file per line? Do you remember? We type ls-1. Now let's say we want to rename hello.txt to something else. Once again, we can use the move command. So we type H, press tab to get auto completion. We can rename this to hello-docker.txt, or we can move it to a different directory. For example, we can move it to the etc directory. And here I'm using an absolute path because my path has started from the root directory. Now in this lesson, I don't want to move this anywhere. So I just want to rename this to hello-docker.txt. And if you're wondering how I remove this entire word in one go, I press Ctrl and W. So let's bring it back, hello-docker.txt. Take a look, good. Now let's see how we can remove one or more files. To do that, we use the rm command. Now here we can type one or more files. So we can say file1.txt, file2.txt, or we can use a pattern. For example, I can say, I want to remove all files that start with file. Let's verify it. Beautiful, we only have hello docker. Now, let's get out of this directory and remove the directory itself. So we type rm docker. Now we get an error saying Docker is a directory. So to remove directories, we have to use the R option, which is short for recursive. So we want to remove this directory and all its content recursively. Now we press D, tab, beautiful. So let's verify there's nothing here. So let's quickly recap. We use mkdir to create a new directory. We use touch to create a new file. We use move to move or rename files or directories. And we use rm to remove files and directories. Now, as an exercise, go to your home directory, create a bunch of files and directories, rename them, and then remove them. In the next lesson, I'm going to show you how to view and edit files. All right, let's see how we can edit and view files. So earlier, we briefly talked about Nano. Nano is a basic text editor for Linux. Now, on this image that we are running, we don't have Nano, so we have to install it. Do you remember the command for installing Nano? That is apt install nano. All right, now we have Nano, so we can launch it and optionally supply a file name. Let's say file1.txt. So here we have a basic text editor. We can type whatever we want. And when we are done, look down below. The shortcut for exiting is Ctrl and X. So I'm going to press that. Now it's asking if you want to save the changes. So we press yes. And here we confirm the file name. We can keep the same file or change the file name. Let's go ahead. So now in this directory, we have file1.txt. Beautiful. Now to see the content of this file, we have a few different commands. The simplest one is cat, and this has nothing to do with cats. It's short for concatenate. So later I will show you how we can use this command to concatenate or combine multiple files. But with cat, we can also see the content of a file. So if we say cat file1.txt, we can see the content of this file. Now, cat is useful if our file is short and fits on one page. But if you're dealing with a long file, it's better to use the more command. Let me give you an example. So I'm going to use cat to show the content of this file, /etc/adduser.conf. This is a really long file. So if I scroll up, look, we have a lot of text. Now, sometimes you don't want to see all the content in one go. You want to scroll down. You want to go page by page. This is where we use the more command. So more /etc/adduser.conf. Now down below, look, you can see more 15%. So we're seeing 15% of this file. Now if we press space, we can go to the next page. So now we're at the position 33%. Alternatively, we can press enter to go one line at a time. Now the problem with more is that we can only scroll down. We cannot scroll up. So to do that, we have to use a different command called less. So to exit here, we press Q. Good. Now in this image, we don't have less. So once again, we have to manually install it. So apt install less. So less is a newer command that is supposed to replace more. Let's go ahead. Great. So let's look at the same file using the less command, /etc/adduser.conf. So now using the up and down arrows, we can scroll down or up. So just by pressing up and down arrows. We also have space. We can go to the next page and enter, just like the more command. And when we are done, we can press Q. Now we have a couple more commands for viewing the content of a file. We have head, which we can use to display the first few lines. So here we can supply an option and say the number of lines we want to see is 5. Let's look at the same file. So this shows the first 5 lines of this file. Similarly, we have tail, which shows the last few lines. So we supply an option and say we want to look at the last 5 files. That's it. So to recap, we can use nano to write something to a file. We can use cat to view the content of small files, less to view the content of long files in an interactive way, and head and tail to view the first few or the last few lines of a file. One of the important concepts in Linux is the concept of standard input and output. So standard input represents the keyboard and standard output represents the screen. But we can always change the source of the input or the output. This is called redirection. Let me show you using a few examples. So we talked about the cat command to see the content of a file. Let's say file1.txt. When we execute this command or this program reads data from this file and prints it on the standard output, which is the screen. That is why we see the content here. But using the redirection operator, which is the greater than sign, we can redirect the output from the screen to, let's say, a different file. So now a different file. So now cat will read the content from this file and write it to this file. Take a look. So we have file2.txt to concatenate or combine, read the data from both these different files. We can use it pretty much any. Hello. So if you want to run, now here's for a few seconds. Then we specify the path. That's where we finish this lesson.